Right, start again. Round 2. At least it didn't take me an hour to get to this stage. It's only 10 minutes. So what's happened is we are going to go through this repo. The very nice people. Let's have a little look here. I've just gone right there, which is totally where we don't want to go. And it's Dimitri and Veronica, and they've set up this repo. I don't think it's just them, to be honest. No. Oh, yes, it is. It is just them, it seems. Oh, no, there's lots of little contributors. I think people have just been helping out. But the idea being is you're able to fork this repo, get it down to yourself, and each time you create a PR for each chapter, so we'll go into source, here's all the chapters. Okay, we'll work through them, and each time you do one of them, you do a PR. And then, if you want them, you can at them, either from 99911 or that one. CH. Oh, Ron was in a stream yesterday. I'm sorry. I should have sort of noticed. I'm bad. I can't connect name. Well, I'm just crap at names, really. That's what it is. And then once you've got the repo down, you can start going. But if you haven't got Haskell, like on your system, there's some really good instructions here that sort of goes through it, either on your PC or on your Mac. And I guess it would be similar to Linux. Yeah, Linux or Mac OS. You can use GHC up. So let's pretend that we're doing that and we've done it. Good job. Here, I'm not using it, but you can download Visual Studio and the Haskell plugin. And Haskell plugin will come with a thing called, I think it comes with, shall we have a little look? I'm pretty sure it does. From memory of looking through it yesterday. Yeah, cool. There we go. Look, it's got the Haskell language server. I don't know if is that. I'll zoom in a little bit just in case. Yeah, it's the Haskell language server, which is like super useful, which you'll see once we're working through things. It will make sense. So you just attach that plugin to VS Code, and you're away basically, and then you can just get started. And it looks like they've created some make files, which I haven't. Let's have a little go. Oh, what's going on? Keep the project in the project list. Oh, what do you mean you can't read it? Yeah, just do it. There we go. Let's have a look at the makefile, what it does, because we're going to look at that. Oh, okay, so it'll do a cabal clean. Oh, here we go. Yeah, so that's all the different ones. So it'll just run tests. So you can test each chapter. So you can test chapter 1, which is basically doing... so you don't even have to type in all this junk. Well, it's not junk. That's how you run cabal. And cabal. Let's explain cabal. Let's have a little look. Cabal is a little bit like npm in JavaScript, and what goes on with that is you basically get it's where you sort out your packages, and you name them. Actually, we'll show you the cabal file. I went through it all yesterday, but I don't know. I mean, it can be a little bit intense. You can use it much like npm. You can do like npm install whatever the name of the thing you want to use. But you can do the same here. And if you look, where have they installed? Where are they? Oh, they haven't. Oh, common doc sets. Where are they? There. So they've just brought that in. I thought they'd be a bit more. But anyway, yeah, and in here you can sort of tell what your chapters are going to be, what's going to be inside of them. So you can see here, like, if it'll go to folder test. And this one here will go to, this is the one we're going to be working on. So it'll go to your source, and inside there, there'll be chapter 1, 2, 3, 4, and they tend to be named similar. So if you see, look, that does test chapter 1, well, generally that's how you name things. And then if you sort of go further in, so you'd have like, Bob, you'd have source Bob, / Bob. Then if we go into chapter 1, it's a little bit further down. Here, that'd be like bob.chapter1. That's kind of something that you go through. Oh, look, this is from yesterday, but we'll be cool. Cool. Okay, so let's imagine that you're at this point. Everything's hanging. You're doing well. You've got, your preferred IDE open. Mine's, I'm on Emacs. Well, I'm on Doom Emacs. That's where I do things. And then I'll just quickly demonstrate. Does it show you? No. Maybe a bit further down. Is there anything further down? Maybe. Here we go. Last digit. there we go. That's what I get. What you get out of a Haskell language server. You can turn this on and off. This is like for the docs. So sometimes if you're a bit stuck and you want to know what's going on, you can turn it on and it'll just show you exactly what's happening, which is really cool. And then for me on the right hand side here, it gives me the errors. It also, well, here it's not an error, it's a warning. So there's 17 warnings. But yeah, we'll go through them as it goes on. Cool. Okay. So we'll kind of go through a little bit. Okay, so happy to see you here on the way, wonderful functional programming land. So yep, we're ready to get the monad dragons and save the globe despicable runtime exceptions. What I'll do is I'll go through. It does actually explain. Last time I would end up explaining things from get-go, but it actually does go through it, which is much better idea. So we appreciate your curiosity. Yeah, I do. Honestly, if you're like coming and you're going to Haskell and you're thinking, what the hell, Haskell is, it's I guess, hold on. It's kind of like surrounded in like the ivory tower, you could say, everyone, because it's long-term background has been academia, and there's a lot of very intelligent mathematicians that are involved, and those people are just like boom, they're just coming out with just brainwave stuff. Me, I've come in, I don't have a degree in maths, like I think, to be honest, maths at school, so when I finished with like 15, 16, I think I got D, right? So that's my background in maths. So basically, you don't need to be an absolute brain box to be good at Haskell and really get all of its benefits that you get from it. And once you do Haskell, if you say you enjoy front end programming more, oh, hold on, I'm going to read this. So the interesting then 2 months Haskell IDE support. Got to use GJ code base on types in your editor now. Oh, you can. Yeah, I'm on 5.0, but I haven't like fully played with it. I know it's like it can help you like do all your imports, much like, because that's what I was going to mention next, was if you're still into front end stuff, that's when you can start doing pure script, which is like super close to what Haskell is. It's almost 1-for-1, but it compiles to JavaScript, which means you can use it on the front end. So you get all those sort of niceties, because the what's the pure script one? It's called PSC IDE. That's like super good. And oh, hello, Chexa. Nice to see you. Welcome to the stream. Strict Haskell with anonymous records. What jokes did you miss? I mean, what jokes didn't you miss? I've not been too joke heavy today. I think I'm a bit more joke heavy when things are going wrong, which was like yesterday. That was like, I was on prime jokes because I had to make up a load of crap whilst things were going wrong. So that's what I did. I just came out and talked a load of rubbish. But yeah, so you could use pure script on the front end, which is really cool. And I'll probably do some pure script, I reckon, because I do enjoy it. That's where I started, because my journey was JavaScript. Well, first HTML. No, actually, it was beyond that. It was PHP via WordPress. So it wasn't really, well, I guess it's PHP. And then I went and learned JavaScript, because I thought, well, I'm not going to keep doing it. Just chatting. Yeah, no, I'm going to do some code. Look, I've got an IDE open today. And there is going to be some code happening. Okay, we don't care about my history. Typo systems. There's definitely typos in everything I write. Right, anyway, yeah, so I did JavaScript, and a lot of people go from JavaScript and they do Elm, which is another cool language, but I didn't. I went straight into pure script. Was that a mistake? I don't know. I don't think it was. I think people can go from one to the other. Potentially it's a lot easier now because there's a lot more content out there, but yeah, when I did it sort of 4 years ago, it's a bit harder. And then I was really lucky and I got a job working at a place called Slam Data, where some of the core contributors at the time worked at that company, so I was surrounded by really good things. Need bigger fonts. I mean, just get some glasses. Yeah, go on, I'll zoom it in. How big? Almost double the size. I mean, It's going to blind me. Is this good enough? I've gone up 2 lots here. You let me know. Oh, there's going to be a delay, isn't there? Okay, then. One more. Okay. Yeah, there you go. Just for you. Because, yeah, is that okay? Cool. Forgot what I was saying. Something about, so I was working at Sam Data and they were all like really good and I got massive imposter syndrome. But from there, then got onto Haskell because at the time there just wasn't many jobs in PureScript. But there is now. There seems to be a lot more. So that's cool. So yeah, all in all, from 4 years ago, why I'm saying all this is there is a reason to learn this stuff. Are you still an imposter? I think, yeah, imposter syndrome for life, I think. Because that's kind of like a good thing, but sorry, it's a bad thing, but it is really a good thing because I always remind myself that why I enjoy doing Haskell and PureScript and stuff is because there's so much to learn. You're not going to get bored. That's the way I sort of sell it to myself. Selling it to myself. I'm just thinking, okay, well, if I feel dumb, that's good because I'm going to have to learn something else and then I'm not going to get bored. Yeah, I know. That's probably like a bad start. I started with like some really good people and then I sort of measured myself up to them. And the other thing you always see also is like people come in and they've been doing it for 2 years and then they're like amazing and you just go, you sod, why you got so good so quick and I'm still here struggling. But it doesn't matter, I think it does go in slowly and you probably know a lot more than you think. But yeah, so the point being is it's languages worth learning because once you get into them, honestly, it's really hard to go back to especially type system, not to have a nice type system. Because you'll see the benefits. I'll go through them once we go through this. But yeah, and it's more companies that are employing doing Haskell, so why not? You might as well. The community is clearly growing, and unless you want macros for my ID or macros for, I don't know. I mean, yeah, I don't know what you mean in macros. Sorry, man. They're gotta be. Oh, okay. Yeah, they kind of are. I mean, you can. The last company I was in, they used PureScript as a backend language, and then I'll just finish and I'll answer the questions. So they were doing backend language, and because PureScript can compile to multiple languages, this one compiled down to Erlang, and they built a distributed system that dealt with doing CDN for video, streaming video. I mean, that's the irony. So I worked at a streaming video company and I struggled to get OBS going, but what can you say? Yeah, so that, and that was all written in Purell. One of the guys that worked there, he built the back end for Purell, and yeah, it was wicked. Like the stuff it did was just, it's really impressive. So yeah, they're quite similar. I mean, you can get it, and a lot of people sort of go, oh, Haskell's for the back end, PureScript's for the front end, but there's kind of a debate that you get quite a lot out of the Node ecosystem. So yeah, you can use, if you want, you can happily use PureScript as a back end language. So TH is so scary. So I started learning Haskell as well and loving it. Yeah, cool. Glad you are. W Gaffer. Waffer. I'm going to go for. Sorry, I've got a terrible sense of humour, so I'm not being offensive. I'm just like that. TH to her. The is so scary as a streaming company. Definitely YouTube. Me working for YouTube. No, it wasn't YouTube. TH. What is TH? Template Haskell. Oh, yeah. You'll see that I'm definitely. Yeah, I mean, you can. I've not really sort of experimented too much with template Haskell. I mean, I've used it like in things like Yeasol and things like that, and yeah, it can be ugly if you're going to do it, but you could definitely. I've been in plenty of production apps that don't use a line of template Haskell, so I won't worry too much. Right, okay, back to learning Haskell for beginners, because I just ranted again. Cool. So you practice your functional skills and choose your class in the end, who you want to become. So this bit was a key point, and I'm going to have to go over it again, you know. So what would you like to be? A monad wizard, an exceptions crusher, a recursion priest, a free fighter, a composition warlock, and many more. I went for many more, just to that. So, you know, any of them you can be. Or you can just be a priest. Yeah, well, you can be a priest if you want. That's fine. It's cool with me. So here is how it works. Make sure you've got familiarized yourself with the repo README. So yeah, we kind of like blasted through the README, but don't worry about it. For each chapter, so this is just a little bit of a catch up of the README. So now we're on chapter 1. Cool. Here we'll learn some concepts. So we're going to do like Haskell language main particularities, how to use Haskell interactively. Oh yeah, that's a cool little bit. Expressions, types, it's like some basic language syntax, so calling functions, if then, defining local variables, how to write your function from scratch. That's cool. No, I haven't. I started yesterday, and I literally did lots of talking, so I'm just going through it blind. It looked pretty cool, so yeah. I don't think. I mean, it is like beginner stuff for sure, and like, well, whatever. It's still going to be hard if you've never done it before. So it's interesting, you know. The thing that I always find it's cool is watching other people do it. They you know, what you can't get from a book is people can like talk through what's going on. Sometimes in a book it's just a bit, and that's the other thing. Like, the mathematical terminology that's used in books is just like, yeah, that does my head in a little bit. I know it's a good thing because it means that it's terse, and you know, you've got like you can be very specific in the language you use, but you know, I'm not very good at that. So yeah, I like simple words. So we're leaving a number of tasks after finishing PR. Yeah, that's when you can add them. Bam, there you go. You can add them inside your PR, and they'll come and help you out. Super nice. Yeah, okay, so we're starting. Let's do 2 little things here. So if I do save, you'll see I get a parse error, and hopefully if you've got VS Code, you'll get a similar vibe. Yeah, it's definitely it's so much better to put things so better with exercise to help you put things to get in practice. Yeah, definitely. There's sort of more advances repo like that, because ideally I went head deep in just doing loads of books, and I was just trying to ram it in, and really I should have spent more time just coding and practicing and getting things wrong and then understanding. Because like, for example here, so I've just uncommented, or I've just actually killed a lot of stuff. Where is it? Up here. Oh, what have I done? Let's go back. There we go, single line. So I've just uncommented that, and here you've got a compiler telling you that there's like an error. For a good sort of year or two maybe, I was really just pissed off at the compiler. Just be like, oh, why have I got it wrong again? God damn, I'm so rubbish. That sort of vibe. But really, you've got to make that compiler your mate. You know, it's got to be your friend, because it does help you. And it's not, when you get things wrong, it's not like you're trying to convince a compiler to, it's just helping you. And really, the more you do it, you end up coding in a way that you're kind of like questioning your compiler as you're going along, rather than, and I'll be honest, you're still going to get those moments where it's bloody horrible, but as a general, let that compiler be your friend, because it's just there all the time, and you can question it, and as we'll display in a bit, you can like do things with it, and it'll tell you. So it's really cool. Okay, so that's the double. So if you want to do that, that'll comment out any code, and this one's for a block. You don't need that. That's just saying here in this repo, when we're using that, that explains various concepts. Okay, so all the code in Haskell is organized into modules. Each module corresponds to a single file. Cool. So that's what I talked about. So modules then can be combined in a package, but you don't need. Translating another language to Haskell is useful too. Oh, okay, yeah. So you mean like, I don't know, like, what would be another language? Python. So you do something like that. So you like did a Pong.js game and then you tried to convert it to Haskell. That's cool. Oh, put it into PureScript, even better. Cool. And then that's how you sort of got started. Yeah, that's a good way to get started. And I think there's quite a lot of repos out there, so you can kind of like. I still really. Oh, here we go. Look, mega cheat. This is a lot. Okay, if you've not seen this before, it's a regular thing that I do on GitHub. Here we go. So I'll go for file name. Okay, and then I'll do .hs, and then I'll just search for the term I'm looking for. So if I'm looking for like something pretty complex, you know, that I've not, because that's the other thing, because the communities are still growing, documentation isn't like the best at the moment. So if you want to see things in action, I tend to do this, and I'll search for, I don't know, what would be, let's go for traversable, let's say like that. Yeah, all of GitHub. And then there we go, you got loads of little examples of traversable being used. So yeah, that's like a really cool little thing that I do. Especially if you've got libraries, and the libraries like look really good, but they don't do them. Napoleon Dynamite. Yeah, I wish I had his hair. I can't. Maybe I would have been. Yeah. Hoogle. Yeah, I know there's Hoogle, but Hoogle. This is what I'm saying. I've got Hoogle. Look, it's on the thing. That's another one you can use. Yeah, so that'll do the same thing. That's it. Exactly. Thanks. Checks that. That's exactly what I'm saying. There's not always examples. So let's have a look. Where's the class? Okay, well, it's not the best thing to look for. But let's just have an example. Actually, this is probably a good one. Here we go. Map M. There we go. So this is your example. Map each element of a structure to a monadic action. Evaluate these actions from left to right and collect the results for a version that gives you. See the results. Map M. P. Map PM. Yeah, so yeah, it's. I mean, it makes sense when you read it and you know stuff, but if you don't, and then a lot of times like, oh, just look at the types, you know, you'll get it. Yeah, you will, but it's not. It's still not as good as like just a little example. Just show me like a little how it's used. That's all I want to see. It's great for exporting. Oh, I get a snowflake. Is that me being a? Is that what it is? You're calling me a? I've only just. This is my second stream. I'm a snowflake already. Got to learn the hard way. Stop requiring everything. Fair enough, man. I mean, I am complaining, but I'm not. I'm just saying that like there's ways around it. So no. So Haskell and PureScript docs are getting better though. They are more, yeah, definitely. And these guys on here are definitely not. Oh, he's not. Oh, you're not my friend, buddy. I'm not your guy, friend. Yeah. And they are. The docs are getting better for sure. It's there's been a vast improvement, and these guys have really. I've done like a few little bits of OSS with them, and they've been really helpful. And on top of that, everything they do is like really well documented. And I think it's just inspiring other people that, you know, the types isn't going to cut it anymore. You just, you know, we want to make this a little bit more friendly. Right, let's keep going. Stop talking. So there's our module. This is how we do it. So all this junk normally wouldn't be above, but in this scenario it is. So in Haskell we have expressions. Expressions could be represented by some primitive value. So you know, like a 1, a 100. There's the characters A or Z, booleans, true or false. No more chat messages for 5 minutes. I mean, you can message away. It's cool. I'll just ignore you. Right, so, or by the combination of the primitive value and other expression using language syntax constructs. So you can have if, then, else, let in. I'll show you that later. Case of, that's another cool thing. Yeah, etc. Yeah, this is cool. This is like a, oh, I won't go into it now. And various function additions. You can do plus, division, div, maximum, max, things like that. Sort, you can do some sorting. Sort by, sort on, and variables. Okay, functions are also expressions as well as variables. So what that kind of says is you can have my var. Okay, it's not going to show up. Hold on a second. My keyboard is new. Okay, just don't worry about it. There we go. Ah, why didn't you just do it? Come on. There we go. Whoopsie daisy. No, I wanted you to do that. Yeah, I'm on a new keyboard, sorry. Cool, there we go. So what it's saying is my var, I don't know, let's say it's an int, okay? And my var equals 4, okay? There it is. First class functions is what it means, yeah. I think so. I think they go into first class functions in a little bit later, yeah. They explain it. But I guess this little point, it seems like expression as well as variables. So this can be, is that what it's saying? Functions are also expressions as well as variables. Yeah, so if you look at this, right now, it's a variable. But then if we sort of do, oh, under the hood, it does the same, doesn't it? Yeah. Anyway, I'm jumping so many things here, but whoops, there we go. So we're just saying that's our input. That's what this arrow is. It's going to explain later, but I've jumped, thanks. And that's our output. Okay, so we're just doing input is whatever, we're going to name it A, and it's got to be an int, and we know that ints work with plus, and so 4 plus whatever you give it. Okay, so that's what that is. We'll play with that later because there's a little bit where you start going in. Yeah, that's me. I was giving examples. Okay, so if an expression is a combination of, where am I? I'm about here. Yeah, if an expression is a combination of other values and expressions, it can be evaluated or reduced to primitive value. The evaluation process is not immediate, since Haskell is a lazy language. Okay, so what that basically means is, oh, thanks for the follow. Okay, I named you Guaffa. Sorry, W Gaffer. I know, I'm just pissing about. Okay, so what it's essentially saying, it's lazy, and what that means is, I set up that function up there that was expecting an integer. It won't evaluate until it's actually run, so it will just sit around. Oh, you're not sure why you didn't? Well, give it time. It's like, you don't want to jump in a deep end and just follow someone nilly-willy. I could have been a right boring git, and then you just been like, why have I followed him? And then I'm going to get emails every time he goes online. Yeah, you did right. Just give it time. It's like a fine wine or something like that. Don't know what I'm on about. Yeah, so lazy language. Cool. So any functions essentially aren't going to be evaluated unless they're really necessary, so unless they're called. So you're thinking, well, what do you mean? So it means that things can just sit around waiting to be used, and they'll never be put onto the stack. They're just waiting. So it's lazy evaluated. There's a bit more, but I guess what they say, you can see the evaluation result either by running a Haskell program or by playing with some functions in interactive interpreter, which we're going to do in a bit because this is how far I got last time. So Haskell is a strongly typed language, and that's what our type system was. That was it'll show you later because I keep jumping things. So it's a strongly typed language. Each value and function is associated with some type, so that's what that business was. This is when you're declaring a type, boop, boop, like that, and then we'll give it a type int. Okay, that's what it is. And then below so that's your type definition above, and then below is your declaration. So you're saying that this function, or whatever it happens to be, hello, is of the type int. And then in here, you can't make it like this. The compiler will fail if you say, oh, it can only be like that. If you say it's that's going to fail because it's going to say, well, I expected an int. You gave me a char. What are you doing? Suck up like that. It's not B.A. Baraka, but maybe we could give like the compiler a voice. No, that'd be really annoying. Like an annoying sat nav. So strongly typed language, yes, that's what it's basically saying, which means that each expression has a type and a value and functions associated with those types. You can't change the value type. You can only pass in a value to some function. So yeah, it's just saying what, if like that we had a function went from int to int, you can only ever pass it an integer, and it can only ever return an integer. You'd have to change the type for the return. And secondly, an important one is every function, I think it goes on a little, does it say pure a bit further down? No, I thought it would be. Anyway, and the other thing is it's pure. So what that means is every time you give it the same input, it'll give you the same output. That's 1. 2, it can't do side effects. So you can't have a function that says int to int, and then in the middle of it, it actually does, make a balloon. Can we write a program which interprets compiler output into natural human language? Then we can do text speech and can literally talk to you. Yeah, I mean, when you say we, is that the royal me that doesn't include me? Because, you can definitely do that. let's just quickly. Oh, I think I saw it in another stream in Vlad's streams. He was on what is it? Reddit, and someone saying, "Oh, what's the best way to learn Haskell? Just write your own language." That was like the top one. Cool, thanks, buddy. That's exactly what I'm going to do. Anyway, type in statically typed. So furthermore, have I read that bit? I've read that bit. Static type of Haskell is a type inference. That means that you don't need to specify the type of each expression. So when I sort of said in a type, I went like this, boop, and you can do this. Watch that. Okay. You can do that. Well, yeah. Let's just say you can do that. So that's basically mean that A can mean multiple things per se. It depends what's in the function, but that's what it means. As a simple terms. Okay. So going to be found out each expression and sub-expression by a powerful compiler. Yeah, so that's where the compiler will work it out. So you'll go, okay, well, I don't, it's just an A, and then you can give it all the things. Oh, you mean on stream? I'll support you. I think you should start your own stream. It's a great idea. You can make the the Haskell compiler errors be a Baraka. Or I mean, you can have it your own voice if you want. I don't mind. I'll listen to it. Yeah, maybe. We'll see. We can get a celebrity or something. However, you are strongly encouraged to write top-level function type signatures. Oh, so well, I went a little bit too far, but it basically means it can just work out. It can just work out that that's going to be int. But it's a good practice. You always put them because so this plays a role in two part. One, it's just a good practice to have. Two, it's really useful because whenever you look at functions, sometimes you look at function and you say, I don't want to knock JavaScript, but that's the language I know the best. But you'll see a function and you'll see a bunch of letters and you'll be like, okay. What does that do? What is that? What's this supposed to be? And you don't really know, But with that type declaration, you've got it at the top. You've got it written. It's going to be an int. That second's going to be a character. That third one's going to be a bool. So you've got exactly the idea of what's going on just from looking. Okay, so this explains a little bit how it does things, which is cool. So once you've written your program, then it'll be passed. And then it'll be compiled, and then it'll make an executable, which is what. So the process of that is once we do this, we'd run something called cabal run, which would be much like npm build, I guess. Yep. And but let's not forget that. We'll go on about that. Yeah, and then that creates an executable. And that executable is then run. So the thing is, you have to do is you can't ever get to this stage without a compilation, and the compilation is what the compiler does. It's catching your errors. So technically, you obviously you can still get some form of bug, maybe some weird edge case side scenario, but you're going to be fairly 99% certain that if you've got past, I mean, you do like anything, you can get around it and you can make errors, but let's pretend that that's not the case. It's highly unlikely that you're going to get something that's going to go live that the compiler hasn't caught an error in. And where that's also useful is refactoring. So say you have one of these functions that has types and you go, oh, well, I don't want it to be an int anymore as an input. I want it to be a char. And in all the places that use that function, the compiler will go, well, it's here, 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 and here. That's using that function. And you told me that it used to be an int, and now it's a char. So you got to change all these other locations. Super useful. So how many times you think, well, I mean, it's happened many times to me. I've just done to change one little bit, and then it turns out that I've missed loads of bits that didn't, and then you get runtime errors. Boom. So yeah, so the idea is because of this compilation, the fact that we do all these types, and that helps the compiler, check your program, make sure that it's cool and working. Okay. And then in languages like Python and JavaScript, they do a parsing, interpretation, and then evaluation. So what does it say about it? Yep. So that's a different workflow. So yeah, this is runtime. So we catch our errors at compile time, so before it goes live, and JavaScript and Python and things like that, it won't. It'll do it at runtime. So once your program's already running, that's potentially when you're going to find your simple errors. It'll be then, unfortunately. So yeah, it kind of feels like maybe there's hold on. There's a bit of an overhead maybe to writing types and thinking about stuff, but in the long run, that overhead's, it's way better. Okay, so you can open up the terminal. So now we're going to see, what does it say? Most of the time, working for Haskell, especially learning Haskell, you use GHCI to play with the functions, behaviors, and export API, blah, blah, blah. So it's a REPL. Yeah, GHCI is a Haskell REPL. And you can play with it. I'm going to do it straight in here, but actually I'll just show you quickly. They just run GHCI. I don't think I've got it installed. Shall we see? You're going to want some zooming, aren't you? Yeah, okay, I'm zooming. Oh, that's great. It zooms one, but not the other. Cool. Let's go zoom in some more then. Boop, 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 boop. And this is going to go off. Because iTerm loves doing that. When you zoom in, it sort of extends the window as well, which is like, thanks, really cool. Have I got GHCI? Let's have a look. Oh, I do. There we go. Cool, we're in now. Can I import anything? I don't know if I... let's have a look. What were they called? Chapter 1. Is it going to find it? No, okay. Well, that's how you get into it, but I don't know why it might not be working from here. Let's have a look. It's giving us some help. I thought you could just import. You know what? We'll pretend that, that's really hunky-dory and it works, and I'm just going to run it here. Because I know it works in here. Basically, I'm cheating. Okay, so just got to wait. There we go. So this is a compiler. So I've just compiled this, and now we're like in a little environment where we can play with it. Okay? So that's what's happened. And it's going to ask us to run these things. So let's have a go. So here, 1 + 2. Okay. What do you reckon is going to happen here? Hopefully obvious. 3. This stuff is just warning. I mean, yeah, you can tell compilers to do different things and hide specific warnings. This is just that. So you ignore that bit. There's a result. 1 + 2, 3. Cool. Next. So yeah, that's just saying each time you see this guy, that means that's what you type in. Blah, 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 blah. I think. Yeah. So it's just asking us to check it out. Oh, and I just did that in the other one, didn't I? So colon. So if you do colon, you can actually type help. Boop. Or colon ? And that'll give you all the stuff that you can use in the CI. So the two main ones you kind of want to think about if you're playing around here is R for reload. And that'll reload. See, so it says, okay, 4 modules reloaded. So the modules are like chapter 1, 2, 3, and 4. So that's reloaded them. So anytime you sort of change something here and you want to mess around with it over here, make sure to reload because the compiler has to sort of, the environment you're in wants to reload it. So that's that bit. Q, and that's to quit. I can quit it from here, but it goes a bit funky. I just have to shut the browser, the panel, but I'm not going to. Right, task 1. Since types plays a crucial role in Haskell, we can start by exploring types. Some basic expressions. You can inspect the type of expression by using the command in GHCI, short for type. Haha, this is cool. Okay, so we'll go. You can type in just the letter T, or you can actually the word type. Okay, and this, if you're thinking what is false, false is a type, and this is where things like Hugel come in handy. Okay, if you sort of want to So that said, let's have a look. What did it say? It says false if of the type bool. Okay. So if we go search for bool. Oh, I should have gone that one. No, it doesn't matter. Cool. Oh, go back, go back. Oh, I've lost it. Go back again. Here we go. So bool and the constructors, we'll go into that. That goes into that later, I should imagine, are false and true. Okay. So you can think of like, we've got this data or data type, and it's bool, and its two values are false or true. So every time you see a bool in the type definition, you know that it's going to be either false or true. That's the only things it can use. Okay. So if we check in here, we've done what's the type of false. It's going to go, well, false, that's a bool. Okay, and you notice also they're always capital letters. Types are always capital letters. Okay, so what does it say? There we go. So we've explained that. The double colon in Haskell indicates that the type's expression before. So that's just saying, we're declaring it. So the false, its type is bool. Okay, and the same when we were doing poop, its type is int. There you go. Oh, I love these. Sup, hey! I think I've got things sorted. Maybe not. We'll see. There's less jokes and there's more coding today, so I don't know. Whether I'm going uphill or downhill, who knows? You tell me. So your first task is to use GHCI, which we kind of did already. And then we can do the type. Well, we did that. Can't let's do it again. Whatever. We'll cheat. Type true. And that's also a bool. So you see how we used the both constructor. You got false and true, and that creates a bool. Cool. What do you? Oh, that's going to show you it shows you the answers already. I mean, it doesn't matter. Here, that's a char. I'll confuse you a little bit. No, I'm going to do it. Doesn't matter. A, B. What do you reckon that is? Okay. Brackets means a list. So when you see like that, it's, you think, oh, it's a bunch of text. Well, that is actually a list of those. Okay, but don't worry about that. I should probably. I'm showing too much too early, aren't I? It's going to be a bit confusing, but that's what it is. Type 42. Oh, here we go. This is an interesting one. 42. Boom. So you're like, what? What do you mean? A num? Num? Okay, what's going on? Let's have a little look. Let's go look for num. Oop. Class num. Oh, I never know which one to go. We're going to get class. Let's do it. Okay, so where's num? It's in the same thing. Okay, so a num, because you're what? Because there's a class. So in Haskell, it's very similar. That we were doing. So we showed that bool has constructors of true and false. But then, say you have like bool 1, bool 2, bool 3. Let's imagine. Well, they can all be like, they can all be put together and have a higher level, like a class. That's what you call them. And those guys can be part of the same thing. So at the num class, it's saying that all these guys are part of the num class. Okay, so keep that in mind. And then when we look here, so that's saying that 42 is a type of the num class, P. Ignore that for now, but that's what P is. It's saying 42 is of type P, and a type P is of the num class. It's actually a constraint, but don't worry about what a constraint is yet. Yeah, so that's what it's saying. So at the moment, we've not been explicit enough. You know what it was saying before, that the compiler will work things out for you. Well, this is it working it out for you. It's just going, well, you give me 42. It could be a various amount of things, but I'll take it as that. Have I? I've just realised. Yeah, these ones you're meant to fill in. They're left over from yesterday. I was like, why are they already done? It's because I did them yesterday. Sorry. Okay, right. A pair. Right. Oh, it's just close your eyes. Okay. Just ignore this line right here. Don't look at this line. And then we'll paste it in here. So what's the type of true? And then that. Don't look. Now you can look. Okay. So it's of a tuple. This is called a tuple. But ignore that. If yeah, we'll not explain tuples quite yet, but it's just saying it's something that holds two values. Okay, and one of them being bool, and the second one being a char or a character. Okay, so that's that part. So what is the type of not? And not is a function. Okay, what do you think? What is a type of not? Let's have a look. Ready? Boom! It's a bool to bool. Okay, and I'm going to show you how to use it because it might not think. So we know. Well, we've looked at the type of bool, so it's either true or false. So this is a function. You see this little arrow? So it's saying it's expecting a bool. It's going to return us a bool. So clearly, it probably can only do one thing. There's a bool. I'm passing it, which is going to be this. And then it's going to return us a bool. So you'd think and you'd hope it returns us true. Yeah. And if we do that, it returns us false. So you see that function? One input, one output. And it can't ever, it didn't return us a rocket, burn Earth alive. It just returned us true or false. When I say burn Earth alive, I meant like, a character or something like that. It's returning exactly what the type said. Cool, so that's that bit. There it is. What's going on? Confused more by doing T, not false, currying. No, I'm not going to mention currying already. You're just going too far now. Going too far. Just taking it to the next level. By doing T, not false, currying. Yeah. Okay, no, but that's not confusing actually. Sorry, I've just gone totally. No, I was going to ignore you, but I think it'll go on into why that's that. But basically, when you do the type of, well, first and foremost, you're going to have to do it like that. Like so. It's just going to return you not false. It's just bool, because you've given it the first value here. It's already. Well, you've already called the function, and the only thing it can be is bool. Why that is, that I'm going to have to leave till later. But yes, you're just calling not false. You're just saying, well, I've run the type not false. So what can it be? Well, the only thing it can be, since I've passed it its first value, goodbye first value, it can only be bool. Okay, see, I got around that one, didn't I? Hey. And operator, that's a cool one. So look at that. And oh, keyboard, everything's messed up on this. I've got to put it in brackets, haven't I? Can you leave it out? Shall we try it? If you're wrong, I don't know. Damn it, you're right. Okay, you're right. Sorry. But you can't do it. Yeah, I can do it. Oh, that's why it failed. No. Yeah, but that one you have to, don't you? And I can't press up, so I have to retype everything. That's the other thing. If you use it in terminal, you can just press up. Cool. And bool, bool, bool. What's going on here? So that's basically saying, again, like we looked at not, that expects one bool, returns us a bool. Here you can read it like this. It takes one bool, another bool, and the last one. So when you look at these types, however long they get, the tendency they don't get too long. Some special characters function needs. Because otherwise it just doesn't know it. It's how it's because it's an infix. Oh my god! Don't start talking about stuff like that. Okay, so it's a bool, and then it returns. So if you look at types, if you tend to look at the very last one, that's usually what's been returned. So in this scenario, it works just like an and. So you can have true. Try, and would it work in here, or do I have to inline it? I'm going to try it. I don't know about when it's in here. Oh, cool, it worked. Yeah, so true and false is false, and then true, blah, 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 and all that sort of stuff. I should be putting these in, shouldn't I? Have I been putting them in? Yes, I have. Cool, I'm following along. There we go. So that's what that is. And there's a type. A plus. What do you reckon? A plus. What sort of type is that going to be? I mean, you know, normally a plus, it takes two values. So you'd expect it to be something, something, and return something. A to A. No. Close, but it's not going to be that. There we go. You're missing one A. It'd be A to A if you'd like partially applied it. So if you'd done like this, where am I going? I'm going to go like that. There we go. That's an A to A because I've partially applied it. Oh yeah, you're missing one A. Nearly, but that's the same. And you know, like when we went on before, it said that it's a num class. So at the moment, because you know we're just saying to the compiler, here have plus. Well, plus can be used in loads of different settings. So because the compiler doesn't know, it's going to say, okay, well I'm going to make this be still open to any sort of setting. But you got to remember is if you use it in a specific, you know, this A, when it's here, it means that they've all got to be of the same A. Okay, so that's important. So if you happen to, if that A happened to be an int, okay, so those, let's have a look. Let's see if we can make that happen. Here we go. And we'll do one. See what happens here. No, not double. There we go. Right. So we partially applied. Well, we partially applied it here with just one. So we're just saying to the compiler, it's one. You know, you work out what one is. So it's going, well, I don't know what one is. So I'm going to make it num of A, and then I'm going to say it expects one more A, and I'll return you an A. But in this scenario, we've gone, well, that one is going to be of the type int. It's going to go, so you want an int there, do you? It's going to go, wow. So all it is, it expects one more int. It's going to return another int. So you see how the int, you know, even though I've only given it one value, the compiler's gone, okay, well, all I can work with now is ints. Because int is part of the num class. You know, it's like a little, num's like the, you know, the parent. It's up there, the granddad, the grandma. And is it parent or grandma? Well, whatever. And then below is an int. Yeah. Oh, I'm just going to take a sip. I see why you're drinking, Vlad, when you're doing these. It's all that bloody talking, isn't it? Gets a bit too much. Right, so that's what's happening here. I'm... why does that work? Okay, we won't go into it. Let's just imagine. I'm just partially applying. So I've got the ability to, you know, just have that first bit and then it's waiting for another bit. Let's not go into how that magically works, but it's I guess that's how it works. You've got that ability. I didn't think maybe that's like a confusing concept. So when you do it like this, you're just basically saying, here's my function, it expects three things, but I'm going to give it the first one. Okay, so I'm here. Well, that function, it's not gotten to the end. You can see it like it's got to go through these two and then it gets to the end, and then that's when it returns you something. But if you've gone there, it's just done the first bit, so technically it still wants that and that. So at this point here, we've just gone, okay, well, I still want another int, you know. And if you were to name this something, then it would just be a function from int to int, and and this is just waiting for the second input to come in. Okay, so that's quite clever. Why that happens, I'm sure it's going to be explained in a bit. So the type of plus is this one, and then we explained how, you know, we can make it more concrete. The word I think they use further up, but it's a bit scary. It's isomorphism. Isomorphism is the actual word for that. It just means that that's ready to be whatever until the compiler just goes, it's going to be whatever. It's going to be whatever until it's ready. And then when it's ready, it'll go, oh, it's an int. Okay, max. What do you reckon max is going to be? Max. Oh, this gets a bit funky, doesn't it? So odd, A, and then it's very similar. So it goes A. Okay. Let's try and use it. Max. 12. 11. 12. Okay. So, it's taking which one's the biggest out of these two, basically. So if we do max 11, 12, it'll return us 12. Okay. And again, because these are very much like plus, they're ready to be whatever. So they're going to be that's of the num class, and that one's of the ord class, which is like ordering basically. But yeah, so it's just saying that these have the capabilities to be ordered. So it has a concept of ordering. It knows which one's greater than another. You ready? This is where it gets interesting. So we'll do max, we'll do A, and we'll do B. And that still works, B. Okay, so it's doing the same thing. Because a char, so this one would have been to num. Num has an ord in it, an instance. Oh, yeah, won't explain his instances yet, but it's just basically saying, I'm a num, and I'm able to also do ordering. And then this is a char, and I'm also able to do ordering. So I've got a concept, the compiler knows that B comes after A. Yeah, that's in simple terms. That's what it's saying. So the original max is there. Okay. So let's get that one. Let's delete that. Right. We'll minimize this a little bit when it works. This is another great feature. Ready? Watch. No. Okay. Ready? Watch. No. Okay. Third time lucky. Fourth time. There we go. Thanks. Really cool, isn't it? So you got a line, and then this comes up, and you think to yourself, okay, cool, yeah, that's got to be draggable. Oh, it's draggable now. But before, no, I'm not draggable. Whatever. Okay, so you might not understand each type at this moment, but don't worry, because Vince has explained it for you already. You only started your Haskell journey. Types will become your friend soon. Yes, they will. Well, hopefully. Primitive types in Haskell include int, a bool, a double. I'll show you a double. Let's have a look. Will that come up as a double? I get confused with my... here we go. No, it's not gonna... Oh. Variable not something on the side. Oh, I've done it the wrong way around. Derp. Fractional. No, that's not a fractional. What? Oh my god, here we go. Come on, we're learning here. Let's have a look. Let's have a look. I always forget, I get confused with these. So yeah, I'm I'm looking for a job, and I'm having look at what a double is, how it's signified. Sorry, yeah, I've got it totally wrong. So yeah, a double is you end up just giving it the types. It's much like an int, but you just tell it it's a double. And doesn't it have like more? It's like a longer set of numbers from memory. I can't remember. But 0.0 is actually a fractional, which is another thing. Yeah. Okay. We'll ignore my stupidity right there. Primitive types in Haskell include int, bool, blah, 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 char, and many more. You've also seen the arrow. Yeah, so we kind of explained a little bit about that, which is a function. So when you see a, so that's like, remember, like types are usually uppercased. What's this? Type 0.0 double. Would show double. Yeah, you're totally right. Yeah. Are you? I think, yeah. No, are you? Let's find out. Let's find out. I should have done more of this, shouldn't I, when I was learning 4 years ago. So, double. No. Unfortunately not. No, because I don't think, no, because the 0.0, then it becomes a fractional, because it's fractions. You can do it like this, though. Again, I can't remember if it needs to be it, but that'll work. No, it won't work. What do you mean it won't work? Oh, do we need to import something? Hold on, let's have a look. Error constructor not in scope. Yeah, okay. So it's just saying we haven't got it. Yeah, we haven't got double in scope, so it doesn't have actually the knowledge of double because we haven't imported it in this file or in here. It doesn't actually know what double is. But that. Oh, maybe that. Hold on. Did I do it wrong? Let's have a look. Does it do the same thing? No, I've got it the right way around. T is not in scope. What are you on about? Oh, I've done it the wrong way around. Hold on, you could be totally right. You reverse T again. Yeah, I know. God. And you're meant to be learning from me. Oh my god, and it works! So why did the other one? Hold on then. Because I did, look how I put it. I didn't even put the dots in there. what am I doing? It's not. You know when you get nervous and you're learning and you're like, yeah, because normally when I'm teaching, I don't do it live. I pre-plan everything and then you do it the wrong way around. Yeah, man. Okay, yeah. So, I pre-plan everything and I make sure that everything's 100% correct. But when you're doing it live, yeah, there's no luxury of that, is there? You just have to look like an idiot when you get your doubles the wrong way around. So yeah, I guess you can assign it to that then. I guess it's too ambiguous when you're telling it from here. It's just like, what does that give it? I know it's the wrong way around. I know. That still gives it fractional. Yeah, cool. So you can get fractional order. Right, let's go back to it. Stop sidelining. So when you see A, B, and C, so remembering types have a capital letter. When they're in lowercase, it's when you're doing this sort of stuff. When you want things to be polymorphic. Yep. So where was it that? There. It takes 2 arguments. So yeah, so that's just saying, like I was explaining before, A and B is argument 1, argument 2, and the last one is always what you returned. And the return value is type C. Okay. So in this scenario, that's like type A, type B, and I'm going to return you a C. Okay. So unlike this scenario where you're saying, well, that's actually constrained to the class num, which is like, that's going to be of class num, that's going to be a class num, that's going to be a class num. Here, in this scenario, where you're saying that they're totally different types. Okay. Task 2. Is that like little swords? That is indeed some little swords. So after having our first look at Haskell type system, we can do something more exciting. Call the arms. I've got a friend called Arms. So maybe I should give him a ring. Yeah, it's like because I do a bit of skateboarding on the side, basically. I have done for many years. It's still rubbish. Anyway, yeah, so, and skateboarders seem to have really good names for people. And his, unfortunately, is Arms. Not so good for him. He doesn't even have big arms. So I don't know why he was called Arms. Oh, his surname, Armitage or something like that. So Arms. Unlucky. I don't have one. No one gave me a nickname. Apart from just before, I was called, what was I called? I forgot what it was. Dynamite, something like that. Napoleon Dynamite, apparently. That was a terrible nickname. Right, arms, blah, blah, blah. When calling a function in Haskell, you type a name of a function first, and then you specify space separated. Oh, we kind of did a little bit of this, didn't we? Argument, that's right. No commas, no parentheses. You only need to use when grouping arguments. Using other expressions as arguments. So we did like a little bit of that up the top, didn't we? We kind of did it when we were calling not and partially calling things. I probably jumped some hoops before I should have, but it's all good. Yeah, for example, if the function foo takes 2 arguments, the call of this function can look like this. Foo, argument 1. Whoa, what is going on here? Another function with an argument 2. How's that working then? So in Haskell, like it was saying right at the beginning, everything, functions, the results. So say this is like a single, let's imagine that this fun is int to int. Okay, let's have a little does it say down here? Does it show you? No, it doesn't. Okay, let's have a little quick play. So we'll call fun, okay, and that's going to be of the type int to int, right? arg2, we'll imagine that arg2 is an int, okay, so arg2, that's an int, okay, and then foo, we can pretend foo is going to be int, so let's count, so it's got 1, and then this is its second value. Okay, right. So what's going on here? Okay, so how is foo able to take... And arg1 is going to be very similar to arg2. Just going to be an int. Okay. So what's happening here? So if we look, we've got foo. And arg1's its first argument. So we can, we can literally just go, there goes its first argument. Okay, so now after this part, it expects another int, and it will return us an int. So how is this another int? Well, at that point, then fun is past arg2. So if you look, so fun is past arg2. Boom. Fun becomes int. So this then becomes int. And then foo took its first int, and then the computation of that being worked out becomes its second value. And then it returns you an int. See, it's quite cool, isn't it? It's like we're basically at the moment we're able to sort of get these functions, whoops, and compose them together. And this is a function, but it turns into a value as long as that. But say for example, if you know that had been like that, if fun had been char, then that wouldn't have worked because the second value to foo, so that's first value, second value. It expects an int, and now you're saying char, and it'll be like, this result has to be int to fit into my foo. But if you did this, then it'd be hunky dory. It'd be like, okay, I accept it. So that's what's going on with these guys. There you go. Operators in Haskell are also functions, and you can define your own operators as well. Excuse me. The important difference between operators and function is that functions are oh my god, I got burped. I had a lovely dinner. It was like a paneer and cauliflower curry. Oh, anyway, just in case you wanted to know. For example, addition, so plus, cons, okay, won't go into that yet. Append, won't go into that yet. Plus, okay. Diamond operator, okay. Why are they explaining to you? Ah, raided. Thanks for the raid. Karotable. Oh, hello, Lumi. Nice to meet you. I'm new to this streaming game. Hey, thanks for the. Is it raid? Is that what you call it? I think you call it raid, don't you? Thanks for the raid and welcome. Hello, Andiata. Yeah, I'm just going on about Haskell basically. And oh hi, 132 Skybro. Yeah, I'm just going through this little repo, which is teaching people how to do real basic Haskell. At Lumi 12337. I don't know what's going on. I guess it's something that you do. Sorry, I'm almost like a technophobe of Twitch. I'm like the worst Twitch user. Yesterday's stream revolved around me, just not doing anything and talking for 2 hours. It's great. People came to watch, to watch some Haskell. Oh, thanks for the follow, Adianta. I'm gonna say it in a funny language. Yeah, so we're going through this reboot. I've done this. I said I wouldn't do it, but I just did it by habit. Cool. There's like a repo here, and basically it's like learn Haskell for. So I'm doing this for like people that just haven't done any Haskell. So you guys, if you've come from, I say it again, guys. I say guys my meaning of guys is plural. I know it's not acceptable, and you're meant to say like people or something like that. But I've got in a habit of using guys as like a plural, not like as a male or female. Don't go into it, Vince. Don't go into it. But I'm going to try and not use the word. I'm going to say, it sounds a bit weirder, doesn't it? You people. It's just, you got to get used to it, but it's just like, I'm old. I'm 40 something. I'm going to say something. Keep it at that. I know I look fresh and young, but yeah. Anyway, this repo is just about teaching how to do Haskell to people who've just never done it, and it's super cool. And those that fork it can then Rom 911 and Dimitri or Veronica, and they'll come and like review them inside their. What the chapters they've done, they'll come and review it. I mean, if that's not awesome and a cool way to get into Haskell, I don't know what is. And then me here thought, well, why not stream it as well? And, maybe be able to explain things that you might not have got from doing it. So we're like on task 2 of chapter 1, yeah. And we're just going, it's basically taking you into the GHCI, and we've just been messing around and looking what's what and how Haskell works. That's basically it. I'd assume you'd probably know lots of Haskell, but, you know, if it's not that much fun and you already know it, don't stick around, don't worry. I don't even know how many people are listening, so I'll just keep going. I'll talk to myself. Quite happy. I'm selling it, aren't I? I'm selling it. But yeah, otherwise, just stick around for the really bad jokes, because I do them all the time. Potentially I'm a little bit crazy. I don't know. I've not sort of tried to work it out. Right, so we're doing list, append. These guys, I mean, it's showing you them, but they won't make much sense. Like this guy also, we'll have to wait for these to come along, because right now it won't make too much sense. Right, so you call operators in the infix form. Operators go after the first argument, whilst ordinary functions... What does it mean? Because I did mention infix before, so I'm going to demonstrate what infix means. So plus... Whoops. Oh, hold on. Let's do it this way first. 1 plus 2. Okay. That's in its prefix form. Okay, so it's just, is it prefix? Infix, prefix. What ID do I use? I'm on Emacs Doom. Yeah, it's pretty cool, but I also use Nix, and that's not so cool, because it doesn't work very nicely with Emacs Doom. But it does. I got it working, but... that's another 4 streams worth of conversation, so I won't go into it. But no, it's nice. It's nice because I like, you know, you could have like, there we go. I like to be a bit visual, you know. I'm not that nerdy. Basically, yeah, I'm not nerdy. You use Doom as well. Good on you. You're one of the good ones. You're playing with. Oh, okay. I don't know what you're playing though. GUIX, or is that the game? I don't know what that is. Sorry, I'm not a gamer also. So like, yeah, all the combinations of developer, I'm just not your average developer. I haven't got especially Haskell developer. I haven't got a maths degree. I don't game. And I sit in on Saturday nights. Oh, it's like Nixos, but guild scheme rather than Nix. Oh, okay. I mean, I love and hate Nix. I love it because it's way better than Docker. I hate it because it doesn't listen to me. I want it to do something. It doesn't. I guess that's like programming, isn't it? I should just shut up. Just take it. Yeah, anyway, I'll carry on. I've gone sidetracked again. I have to stop myself. Maybe people should message me and say, just get on with it. I don't mind, because I do go off on one. Okay, infix, prefix. Okay, so I showed you that version. And you can do it like this. Because it's a function. Essentially, plus is a function. You know, like we showed above. The type of plus. Let's quickly do it. Type of plus. There we go. So a function is expecting 2 values. So when you put it in here, which way around is it? I always forget infix, prefix. Infix is what's inside of it. Prefix, is after. So no, infix would be the front. Is that right? And the infix form goes after. I need to drop off for a bit. But, yeah, cool. I'll raid him. Yeah. How am I going to set myself some sort of... Actually, I'll raid him if I can work out how to do it. Yeah, that's a deal. Because I haven't got a clue. I think you click a button somewhere and it goes raid. And I'd assume I'd have to sort of like logic with Agda. My goodness. Yeah, that's some hefty stuff there. Right. Yeah, I'll raid him when I'm done. If he's still about. Is it he? I don't know. Raid. You just do it like that. I'm not going to do it right now. With the other slash. Oh, you can just... Okay. Reed is his name. Oh, cool. Reed. Okay, that's a cool name, that. I like that. I've just got Vincent. Reed. That's a bit more interesting, isn't it? Anyway, infix. Let's read it. As I always get these muddled up. You can your call operators in infix form goes after the first argument. Okay, so I was right, yeah. So when it's that way, it's infixed. Another way you might sometimes see it is inside little boop, boop, like that. But in this scenario, it will work like this. And then in the prefix form, if we go like this, because it's a function, much like when we were calling foo and poop and all the other funny named functions, you can do it like this. Boom. So that's its first value, second. Yeah, that's what's going on there. Does it show you here? I should probably read that. Add. Yeah, int to int. Type of plus. Int. Oh yeah, because add and int are the same thing. But anyway, so add. Oh, that's the infix. You know what? Let's go look at the... I can show you. I can show you in the code. Hopefully it'll show us in the code. Maybe it won't show us in the code. Okay, hold on. Let's try this one. Let's try. I'm on Google again. If you didn't get the pun, we're doing Haskell, and it's like the search engine for Haskell. And there's a famous one called Google. So Google. Oh, that's terrible, isn't it? Where is it? This is the other thing. Look at right. Okay. I don't know if it's meant to work. And you go, cool. Take me to source. Okay. Well, I'll take you to the source file, not the location of the source files. But it seems like it should be. Maybe it's not. No, it doesn't. It'd be nice. It'd be nice if it. Obviously, it can't because it's just a single file. But it would be nice if it could just take you to like the exact location, wouldn't it? Again, I'm being a snowflake. I'm complaining. I know. Sorry. I'm trying to show you something. We might not see it in here. There it is. I'm looking. No. Okay, I've just gone somewhere totally non-essential. Yeah, the idea is I thought that sometimes you see here, there we go. That's how it's declared. Sometimes it's got like, it's an infix of something there. So that's like, because that's how I remember things are infix. And so this is the infix version of whatever something is. And usually above you have the name of it. And then it can have an alternate name like add. That's what I was looking for, but didn't find it. Sorry. That didn't help anyone. Cool. So add, you can do it that way, or you can do it this way. So that's in its infix, and that's in its prefix. All I did in prefix here. There we go. That's in its prefix. And here's in infix. There you go. What else is going to show you? Note, in reality, the type of plus operator is the following. Yeah, we did this. Cool. It may look scary. No, we've explained it. It's not scary anymore. Probably was before. Let's see their explanation. It's probably going to make way more sense than mine. Let's have a look. It may look scary to you, but we will cover all this num and that business. Fat arrow. We'll call it the fat arrow. That's what they call it in JavaScript now, the fat arrow. Later, for now, you can think of this as a polymorphic function. Big word number one. Yeah, polymorphic is what I was saying. It's the compiler going, I can be anything. So yeah, anytime you see polymorphic, get it into your mind of me going, I can be anything. And then you'll remember it. I wish I had someone who told me that. In this case, the operator that can work with any numeric type, including ints, doubles, etc., or can even pass the plus D option to the T. Let's rewind. I didn't read that properly. Or you can even pass the plus D. Where's D? I don't know what that means. Option to the type command and simply you type. Oh, hello. Yeah, I forgot about the plus D. Yeah, so you won't get this business. It will say, oh, just, try and, what does it stand for? Let's have a look. What does it actually stand for? Where's plus D? Plus M, plus C, plus, oh, it won't find it. Yes, it will. Plus D, there it is. Expression. Show the type of expression defaulting type variable. Okay, so it's going to default to what it wants, I guess. Well, okay, that's interesting, isn't it? So yeah, we should have done that before. When I further up ended up saying the plus, and then I assigned it to 1, and then I made it an int. Well, it looks like you can just default it like so. Make it a lot easier. There we go. Integer. That's cool. As in the previous talk, try to guess first and then compare your expectations. Okay. Well, you know what? Instead of me just like rushing, if there's anyone about, I'm going to wait because there's going to be a delay. So it's probably 10-15 second delay. So I'm gonna have to sit in silence and result instead of the text. What's it saying? Function. Remember this from your previous task. Yeah, I remember that. So insert the result instead of the text. Yeah, okay, we can do that. Let's have a little go. Okay. I mean, we won't mess with that. Oh. What's it? Yeah, well, no. Technically, it will return us a load of that. But, we ignore that. I think this mainly just happens in here. Not. But yeah, anyway. So, well, we know that's going to be free. Okay, well, okay. Oh, what's this one? What's this one going to be, do you reckon? 10 minus 15. Right, go on, write it in the chat. I'll wait. I'm going to count to 20, let's say. Because that'll give time for the thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No one's typing. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. None of you wrote. Okay then, I'll just do it myself. Thanks for the interaction. God, you have to do everything yourself nowadays. And I didn't even, after all that, didn't even do it right. 10 minus 15, what does it equal? Minus 5. There you go. That's minus 5. Now, take note how the minus has to be attached. It's, because in Haskell, it is space aware. And if it's next to it, that means, but if you go, whoa, if you go minus 5, oh, it doesn't, hold on. Yeah, so if I was to do the next one, we'll show you. So 10 minus 5, okay? So that's 15, but if I was to do, I hope I'm not talking lies. Please don't talk lies. It's still 15. Why did? No, I thought they had to be right next to each other. Maybe it's the other way around. Is it? I don't know. I'm going to play around. Why not? Yeah, now it's getting confused. That makes sense. Yep, it's complaining. It's missing an argument. Give it a flexible context. It's the wrong way around. It won't be in front anyway. What have I done that for? Excuse. I don't know what I'm going for. I thought it cared whether that was there or there. Or maybe, no, because you'd think that, I don't know. 10, yeah. Oh, if it's in, do you reckon that won't work either? Sorry, I've just seen your message if you wrote a little bit ago. I wasn't looking. That won't have it, will it? No, because then it's obviously thinking, oh, okay, so in this scenario, it's thinking that's like a double minus. So that expects 2 arguments, and that still expects another, well, yeah, it's missing an argument basically, because it's got dead confused. Okay, well, 15. That makes sense. Oh, this is a good one. 3 plus 5. You could have, W Gaffer, why didn't you write the answer? I gave you 20 seconds and everything. Disappointed. Just realised you wrote. You had time, I gave you plenty of time there to answer. Have you got the rep all open, or are you just guessing? Because I should have probably gone through that a little bit better. But yeah, if you have, join in. If you haven't, then even guess. Don't worry about it. It's all good. Oh, okay, cool. I usually just use neg instead of minus. Yeah. So you do have the repo open. So even like double, you could have written something. True. Whoa, 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 whoa. How did it get to this? What is going on? Huh? Well, we kind of went over that, didn't we, before? Let's just type in our answer. Why is it true? Okay, let's go over it. So we know that 3 plus 5. So let's break this up. Well, actually, let's start with this. Let's do, like what we've been learning. Let's do it. Type. What is a type of that? It's not going to work. Well done. What is a type of that? Okay, so it's an OR. So it takes something, and returns us a ball. And whatever's of class ORed. So it's got to be to order it. You can cheat and you can use characters here. We won't do it. But like I demonstrated earlier, you can. Whatever's of class ORed. It takes 2 of them. So that would be the first one. And this would be the second one. Oh, I do not have a REPL open. Oh, I read it as you do. Yeah, I should have. Yeah, sorry about that. I'm accusing you of, not being able to answer. Well, still, you can guess. Don't worry about it. I'm getting it wrong, and I've got a REPL open. So, don't know what my excuse is. Okay. So, what's going on? Let's go back. So that we know is a function. It's in an infix position, okay? And it expects 2 inputs. So there's input number 1. There's input number 2. Okay, so because there's brackets here, we know that this computation is going to be run together. Again, this expects 2. Yeah, I don't blame you. Yeah, you said maybe, but it's a bit late, and I'll probably get the easiest math expression wrong. Don't worry, I'll just do it in front of a bunch of people too, so it's all right. At least I can't see your face, eh? It's fine. What was I saying? Yeah, here we go. So this is the first expression, 3 plus 5. And because it's wrapped, it's going to be worked out like that. So we can do the 3 plus 5. I don't even need to wrap it, but let's just wrap it anyway. 5. Okay, so that's 8. There's our 8. So this would turn into an 8. So let's do that. That's our first value. And then this one is less than. Again, it's very similar to all other languages. I mean, I don't know why I'm going over this, but it's kind of interesting. It gets you concepts of, how things are building up to making it into this function. So this is our first A. This is our, the 10 is our second A. So we're saying, is 8 less than 10? True, it is. And it returns us our bool. And we know a bool can be, either true or false. In our instance, it's returned just a type. This is another weird one sometimes. You're thinking, because I guess in most languages, you're used to returning, specific expressions. So like a calculation, you expect it to always return a value. So then when you return a type, what is going on there? How is that happening? Well, it'll come further down, but it's a really interesting concept. You end up using the types as another set of values to be more, because you can do true, you can do true or false in JavaScript, but you end up with things like no, the old nan and stuff. If you get them wrong, it just goes mental. But this sort of stops it from doing that. It's a bit nicer. But that's essentially what happens. You're able to return these truths, and then you'll see later on. We saw there's this thing. It's called case, or you can do case whatever. And then of. Okay, and in here is when you can start doing things, and I think that'll probably be in a later chapter. But I'm just giving you a sneak preview of how you can handle things that are returned that aren't values, that are actual types. Okay, so there'll be a way you can put that in there, and you can put case of, and then you can do some other magic to work it out, but we won't show you now. Okay, just it's just like a sneak preview. Right, next one, true. Well, we know we'll do this again. I'm just sending it home, because the more we do it, or you see it, the more it'll become the fact that we're interacting on the right hand side and we're getting output straight away. So what's the type of and an and? Ampersand, ampersand, or and is bool, bool, bool. Okay, so it's the same like in most languages of the and. It's very similar, always does. So it expects a bool, we're giving it a bool. It expects another bool, we're giving it another bool. And it will return us a bool. And that will return us false. Cool. That should make sense. What's this one? We haven't played with this one, have we? That's or. So look. Oh, I keep doing it wrong around. Yeah, sorry. Wrong button. Here we go. So again, a bool, and returns us a bool. It's like an OR operator. If you do have a sort of programming languages, that's what it is. But we'll demonstrate. So it expects a bool. So we know that less than, which we literally just used there. Okay, so one value, another value returns us a bool. Okay, so we've got of the ORed class. So we know that that's in an ORed class, that's in an ORed class. The result of that is going to be true or false. And then the result of this is going to be true or false. And then this is in the infix position. So this expects two values. So if we looked at it, one value, second value. This is the first value, second value. It's kind of handy. I mean, if it makes more sense, you can do it this way. Okay, because we know it's a function. And then the first value we're going to pass here is like 10, less than 20. And then the second value is going to be 20 less than 5. I'm just searching for everything here. Less than 5. Here we go. Boom. True. Okay, so is 10 less than 20? Yes, it is. True. Is 20 less than 5? No. So basically we're doing, false. No, it'll be false. So we're doing true and we're doing false. There we go. That returns us true, like an OR operator. Okay. Yeah, that's what it's doing. Let's go true. Yeah, that's what. So that's what's going on. And then you can. So that was prefix, and then we can infix it. There we go. And then that is the same. So you can do either or. That is technically okay. It's not going to work with any random function. It's not. When I went into the documentation and I was looking for like the word in infix, that's when you've specifically told the compiler that you want this function to be able to be ran infix. Okay, it's not going to happen. We can't just say, we can't call like let's. Do you have to let in here? Let. I don't think you do. Foo equals. Hold on. Let's do a plus 4. Okay, what's foo? Okay, there we go. We've got foo. So we can't do this. Okay, because we haven't given it a we haven't given it an infix, but we can happily do like that. No, we can't. What's it going to? Oh, a plus 4. Oh, I'm giving it 2 values. It's the expected one. Okay, let's go again. Oh, I can't. Okay. Hold on. Let's go Baz. Baz is coming out. I've made a terrible mistake. A, B, here we go. Again. A plus B. Let's do that. Okay. What's Baz? It's stuck because we're using the plus operator. How has it worked that out? Yeah, because we're using a plus operator. The compiler's going, okay, well this plus operator could only be used within a num class. So I'm going to make all those. And let's try and do the other one we saw. It was plus D, wasn't it? And we'll do Baz. What happens then? There we go. Beautiful. So it expects 2 inputs and it's returning us another one. Okay, so we're just going to prove ourselves that this works. Okay, so that returns 9, ignoring this stuff. It's in green. Green means good. Colors mean something's happening. And then we'll go for baz 5. There we go. It's just because we haven't set up an infix, it's just like, okay, so there's a number 4, then baz, and then what? I mean, what are you on about? Yeah, that's basically what it's complaining. Yep, you could, that's the other time you see it. I think you can. I think you're right. Then you can, yep, you can infix it yourself by using those. I kind of quickly mentioned it. But yeah, you're right. You can make it infix by putting these little backward ticks. Then you're saying, okay, well, you can do loads of other little nifty tricks like that. But you're right, totally. You can do like that. Which is interesting because sometimes it can read better. You know, like the plus kind of like it clearly, you know, it's much better to go like that than it is to sort of, it doesn't really make much, well it does, but you know, it's kind of like, it's a bit like, what's going on there? But it's good to know that it goes like that because then you have a really good understanding that, you know, it's a function that expects 2 values, returns us a 3rd value. And very much the same with baz. You know, we set it up here and all it is, I mean, the compiler converted it to the types we wanted. We couldn't declare the type we want, but it converted it for us. And it was A, and then we did the plus D, integer. It expects 2 values. That's fine. There, don't know what's going on. Put the backwards ticks. That's like putting it in fix manually. And it's going, oh yeah, I'm happy. I'm going to return you an 8. Okay, so that's that bit. This one, power. Again, that we'll just go through that. There we go. So it's 2 to the power of 10. 2 to the power of 10. Yeah. It's kind of self-explanatory. It's 2 times 2 times 2 times 2 times 2 times 2 times 2. I don't know how many times I did it. 10. Not false. We went over not, didn't we? We know what the answer to this is. True. So let's go true. Cool. Div. You mentioned div, didn't you, actually? WGaffer before. You tend to use div. I think you did. I might not be reading it properly, but I record. So div is the version of, you know, when you see that, I guess, divide. So we're going to divide 20 by 3. 6. Yeah. Why is it? Oh, it says it right next to it. I was going to try and trick you and go, why is it only 6? Integral division. Yeah, 6, 12, 18. So it basically, the div will see how many times it will go, but it will ignore the last little bit. So when you do div, it's not at all like, I just totally threw everyone, didn't I? Let's go. That will work. Yeah, okay, that's fine. It's not like that at all. It's totally different. Sorry. Totally forgot. Yeah, so what it's actually doing, so the answer is that, but when you do div, it's just going to see how many times it can actually go into it, and then once it goes over, it's just going to ignore it. So, you know, 6, 12, 18, and then you've got 2 left over. Well, it's just going to ignore it and say, well, I can just do it 6 times. Okay, I can do 3 6 times, and then, but, so we'll put in the answer here. So that's 6. Okay, and then here mod is the opposite. What do you reckon mod returns? Well, integral division remainder. The key's probably remainder. There we go, 2. So when we did the first one, that returned us how many times it can go into it. 6 times. 3 can go 6 times into 20 with 2 remaining. And this one goes, well, 3 can go 6 times, and how many have I got left over? 2. There you go. It comes handy. It might not be apparent straight away, but I've seen it in loads of functions when mods use. When you start doing recursion and things like that. But that's another topic. Okay, max. We played with max, didn't we, before? Max 4 and 10. Yeah, that was quite simple. 4, 10. What do you reckon the answer is going to be? It's going to be 4. No, it's going to be 10. Yeah. So it returns as 10. So again, we can do all this stuff if we want. Let's go reiterate. Let's iterate. Let's do it. There we go. We can do it that way as well. As Well pointed out by W. Gaffer. Paying attention. Extra points. I don't know how I can give you extra points. I think you get points, don't you, for just watching. I've not set up any, like, yeah, sorry. The prize is that you're watching me do stuff and hopefully you're learning. That's a prize. That's the only prize I can offer. You're clapping. Yeah, give you a clap. Well done. Everyone, do the same. Because it was it's good. See, this is another thing. Right, I've got to point out. Even though I've been doing Haskell, like as a career, and I've done it full time. I've worked on really complex sort of code bases. I never think of a junior as someone lower than me. I know it sounds a bit mad, but because that was a prime example, I just totally forgot. I forgot that you can just do the backticks. I'm not saying you're a junior. But let's pretend that you are and you don't really know a lot. Then it's great because you can just learn things off each other. Even if you're a junior, another one, they'll see a good perspective. So if you bring someone to a complex code base, and then they'll be there and they'll be like, "Wow, what's this?" And then it should technically, you'd hope it'd make you think twice about how you're writing your code. Is it overly complex? Because what happens with Haskell is, we've not started. Oh, excuse me. We've worked on like a single. We kind of played with a little bit further up, didn't we? Where did we go when we started doing a little bit further up with multiples? These guys. We've started sort of composing there. You see, that's kind of like with Haskell. You can start doing this, mix and matching things together, and then once they get more complex, you can make it even more elegant and look even smaller. But the problem with that sometimes is you lose it. It's almost like it becomes a game of like, how can I make this as neat as possible? And you almost lose sight of the fact that you're not the only one's going to be reading it. It might be beautiful. You'll get the satisfaction of it being amazing. But then 5 months down the line, you look at that code and you go, well, I mean, it's small. Yeah, it's definitely small and it looks lovely. What is it doing? Ain't got a clue. So that's another thing. It's what you get from juniors. They'll come along and sort of pinch you and go, come on, stop being so goddamn clever. Stop trying to OCD on this beautiful stuff. Just keep it chilled. That's what it is. 10. Those are the answers. Oh, how do you mean? What part you're afraid of? Oh, not understanding things? Oh, getting scared to go back. Yeah, I mean, I don't know how bad your code base is, but let's imagine it's not that bad. Or, yeah, I don't know. I keep that in mind. I always try and keep that in mind. I always think, and I think you learn that sort of stuff in doing. I've done OSS and I've done a fair amount, but I've not created my own library. I'm not like an amazing OSS contributor, but I've done enough to learn from it to sort of feel like it's because that's what happens to developers when they sort of an enclosed environment where it's not going to be open to the public. Well, it's a two-way thing. It's one, you're going to be less, you're not going to be that bothered because you're thinking, there's only a couple of people going to see it. I'll just hack it in. Number two is sometimes you've got like time constraint to, you think, I better do it. Business wants me to do it real quick. I've just become a bit of an advocate to try and, it's not that hard to push back. If it's like critical, because I've worked for a lot of like small, startups, and sometimes you can't necessarily get away, but you can definitely find a middle ground where you're doing enough, but not like way too much and not way too little, because we had a project where the gentleman was absolutely he was amazing. He could code I don't know. You'd come back because we were working internationally, and you'd come back the next day and there'd be like another 20 pages of code, and you'd be like, what is going on? 20 files, sorry, of code. And you'd be like, what? But you couldn't understand it. It's just like, I'm sure you're doing amazing stuff, but no one else can understand it. So how valuable is it? Yeah, you've moved the project potentially on, but have you? Because it means you're the only person that can work on it, and then that's not putting it forward anymore. That's putting it back, because then the speed that you've gained in making it, complex and work, you've lost in other people trying to push it forward themselves. So you'd rather have a code base with 20 people working on it and code base having 2 people working on it. You know which one's going to pay off. Well, that's what I go by anyway. It kind of works. We hope. Right, what are we doing here? Back to it. Should have told me. I'm chatting again. Min 5, max 1 and 2. So we know. Let's go in here. Let's go in here. Let's go in here. Let's go in here. So let's do some of this again. Let's send it home. Don't trace. Min. Okay. We can do. Let's do some of this again. What is it? Plus D, isn't it? Boop. Let's do min. Oh, that's not going to help anyone. Don't do that. Just do the first one. That's much better. Okay. So it's going to take the minimum. An A and A. It's got to be of the odd class. It's going to return us an A. Okay, so that's, we can, we've kind of had a good inkling. So that's the value number 1. That's our first A. And this is it. Yeah. I don't want to explain units yet. It's not, because I guess it is, isn't it? Like memty unit, so it's going to be unit. It makes sense. But it just doesn't, if you're looking at it from the beginner's point of view, it's like, what? So ignore that line. You never saw it. Min 5, max. So 5 is our first value. Our second value is max 1 and 2. So we've seen max also. It's exactly the same basically. And what we're going to work out is min of 5. And then our second value is going to be a result of max 1 and 2. Okay, so we'll see that. And that equals 2. So it's quite easy. What's the maximum of 1 and 2? It's going to be 2. And what's the maximum of 2? Sorry, the minimum of 2 and 5? Well, it's going to be 2. 2's less than 5. So we're going to return 2. This one's a little bit longer. Hey, now we're starting to compose. Now you're getting an idea of how these things start going together. We've got max. We've done the type of max up here. No, we haven't. Let's do it. Let's do it. I've told you what it is, but don't believe me. Let's see it. There it is. It's exactly the same, just like I said, so I wasn't lying. So 1, 2 returns us a third. Okay, let's have a little look. There's number 1. There's number 2. Okay, so that's cool. And then that will return us a value. And this one, min, we've done min, exactly the same. Expects 2 values. 1 value, 2 values. Another. Let's try and work it out manually. So what's the minimum between 5 and 7? It's going to be 5. So that one's going to change to 5. What's the minimum of 1 and 10? 1. Okay. And what's the maximum of 1 and 5? It's going to be 5. Okay, that's going to be my guess. Am I going to be right? Am I going to be right? How's my arithmetics? 5. Oh, yeah. Thank God for that. Got it right. Okay. So because Haskell is statically typed language, you see the error each time you try to mix values in different types. Yeah. Well, let's go further up here. There we go. We're kind of like, it doesn't really, let's go show you a good one. Okay, let's show you a good one. Let's go, let's do, this won't work. Cool. There we go. So let's have a look. So what I'll try and do is, it can be confusing, you see. Because if you don't know what an instance is, you kind of look at that error and you go, what are you on about? What do you mean, an instance? Why don't you just say that plus can't use characters? Okay, so we know that the plus, when we looked further up, let's go like this. I'm going to give like a mega simple. Okay, so we know, so there's a num. Oh, okay, that makes sense. So it's of the type class num. Okay, so we know it works with num. But then, what is the, oh my God, what is it? I'm going to look. There's a way to see all the instances. Is it just I? Oh, let's have a look. Info, I think it's info. It is I, yeah. No, I, what are we going to do I on? I forgot, I've got lost. We're going to do I on plus. Let's go down here. Let's go plus. There we go. So it's not showing us everything. Never mind. It's not I. It's another one. I won't go into it. But basically, the idea of being is you're able to see everything that's plus what class. No, it does show you it. I'm being silly. Yeah, there we go. Look, plus is of the type num. Ignore that. But that's a type class. Okay. So you know it's a type class num. Let's have a look at the error. So it's saying no instance. Okay. We don't see instances here. There's another way to show you those, but let's not do that. Okay. There's no instance of num char. So of the here we go. I can show you. Let's have a look at this. So we'll go back to our trusty Hoogle. Let's go to the class num. Okay. Let's where's our class num? Where's our instances? We'll look for the word there's instances. Okay. So you remember when I was saying that everything below of a class, so we had like int, we had like float, double, okay? So if we look down, is it alphabetically? No, it's not. That's useful. If you look down, there ain't no char, okay? Char's not part of num. So our error is saying, well, I don't see an instance of num char. So it's looking through, whoa, we shouldn't have done that, sorry. I don't see in here, so I've looked at my, where is it? It's up here, isn't it? There we go. Our class num A. I've ignored all this stuff. Methods I've ignored. I've kept going and I've looked for the word instances. There it is. And then what instances have been made? Okay, well, num will work with double. Num will work with float. Num will work with int. Okay, and it'll keep going, and it's like, well, num ain't going to work with char. No, buddy. Yeah, so it's not going to work with char. So ultimately, it's just saying, well, I can't use this plus because I haven't got a num char. There's no way, nothing's telling me how to add these two guys together. What's going on? That's my error. Okay, so that's first and foremost. If you see things, no instances, generally it means that you're trying to mix, you're potentially trying to mix something of a class, or it can be of two different functions. Give you another example. What can we do? Here we go. This would be a nicer error. 2.0, 2.9. Is that going to work? Oh, damn it, it's worked. No, I know what I can do. Let's do this. Okay, let's try it. I don't know why you'd come up with this error, but you might do. Plus. There we go. So it's the same. Here we go. So fractional int. So no instance for fractional and int. Let's do an even one. Poop. I forgot how you declare it. Oh, I could do it in here. Let's have a look. I'll do it in between here. Let's have a look. So foo is going to be of a type int and int, and it's going to return us, let's say char. Okay. So foo a b, and it's going to return us. Look at that. I'm going to ignore the inputs. Okay. So we've got that there. Now let's make another function. Boop. There's our function. It's gonna take in, should we just say int, and I don't know, returns us a char, for example. Okay, so boop is gonna equal, there's an a, and then we can, from within here, we can go foo. Okay, so if we go a, and this is another, yeah, it's not too early to, yeah, I think it's a good time to do this. We can start asking the compiler what this value could be. Okay, so let's have a look. So ignoring that, let's go here. Okay, so that's our error. It's saying, I found a hole. You know when I was saying you don't want to fight with the compiler? This is where the compiler helps you. Okay, so we've made, what have we done? We've essentially made a function called foo, and it takes look at this Haskell. Oh god. Okay, hold on. Ignore that. It's basically, yeah, the way it works, it takes this as a documentation for that. So when we hover over it, we're getting documentation. It thinks that's its documentation, but it's not. Anyway, so foo is a function that takes an int and returns us a char. We're basically doing nothing with those, we're just returning char, okay? But it's a valid function, you know, we're doing exactly what it says. We're taking two values, though we're doing nothing with those values, it doesn't matter. As long as we're returning a char, it's a valid function. So we are. Then we're making another function called poop. Okay, but this, you know, instead of having two values, we want to say that we want to predetermine this value. You know, and we don't know what we could predetermine. You know, you can imagine this is another file, but you got here, and you know you got foo, and you can't remember. So it goes, okay, well, this is underscore, okay? And the underscore is called a typed hole. And this is going to show us the result, what's missing. So it's saying, I found a hole. Well, I found a hole. And it's meant to be an int. That's the value I expect an int. And then here it's going to give you, replace it with all these different things. But you don't want to do that. Okay, so that's supposed to be an int. Now let's try and do this. What do you think is going to happen? So this is a much better error. Let's have a look at an error. Error. Here we go. Whoa, why is it doing this crazy stuff? Look at that. Anyway, couldn't match. So you'd see this. These are all warnings. Normally you just see this. Oh, excuse me. So couldn't match expected type int with actual type char in second argument of foo, namely s. Or like, you know, the char s. In the expression foo a s. So it's, I mean, that's a pretty good error message, you think. So I couldn't match the expected type int. So it looks further up. It looks at foo, and it knows its second argument needs to be an int. Okay? And then you've essentially, or you've not done anything. I've done this. Given it a char. So it's saying, well, no, I couldn't match the expected type int with the type char. Don't give me that. You're like, okay, right, I won't give you that. So we can, yeah, I'll give you an int then, yeah. And then hunky dory, it's happy. It's like, I'll live with that, even though you're doing nothing with my values, but I'll live with it. So that's what's going on there. And where was that described? Let's go. Yeah, so that was the end of it. I can't remember how I got to this. It came to here. Course smalls won't. Yeah, we were talking about error messages, weren't we? Yeah, so that's a nice way. When you see, like, you know, when you start to see instances of, it might be a bit confusing, but in general you're more likely to hit this type doesn't fit this type. So you gave me this, but I expected that. Actually, what was the order it gives it in? Because that used to throw me for a while. You just have to read it good, and it's fine. So couldn't match expected type int. So yes, it's that way around. So the expected, actually it's here, isn't it? So I couldn't match the expected type of int. So the compiler expected int, and with the actual type is the type that you've given it, we've given it, I've given it, of a char of s. Okay, so that's why it's complaining. It's like, nah, not happy. Thanks, but no thanks. Yeah, that's what's happening. Right, shield. We're onto the shield section. What's the time? 20. I said I was going to do 2 hours. Okay, how far have we got to go? We're kind of making good progress, but that's quite long, isn't it? We're getting there. The one error message I battled with for days was not ambiguous. Error. And it was too easy to fix. I facepalmed. Not ambiguous. What? So you didn't make it ambiguous enough. So you made it too concrete. Is that the ambiguous? I don't know. I can't remember. Honestly, you see so many errors. I almost, to be honest, sometimes, yeah, that's what I thought. Sometimes I so heavily use that little trick that I showed, the type holes, the underscore, and I'll make up like complex functions, and I'll start from, so if I've got like a thing, a monad of gonads or whatever, massive function, I'll just start it off and go equal underscore. And then, okay, I know that's the output. And I'm thinking, and this is another cool thing. Can I show you this? Yes, I can. Here we go. You can do this. So say we do foo. Int. Okay, I'll show you another little trick which is really useful. Okay, and then foo a b equals. Okay, let's start there. So we look on the right. So found a whole int. And this is because you just had to add this is a type and it worked. Yeah, sometimes it needs to be concrete and you need to tell it because you're being too ambiguous. Stop being ambiguous. But this is a really cool thing to notice, because sometimes you're going around and you're like, I don't know, what's A? Say you're nested and you're further in and you don't know what's going on. Well, you stick it in a hole. Okay, so it'll come out with an error and it'll go, okay, well, I expect this to be an int. What you've got is irrelevant bindings, including. So what's B and what's A? Well, it's referring to these guys, A and B. Look, let's change names. Ass, boob. Okay, so have a look. See, boob is expected to be. I've got boob in scope, and I've got an ass. This is so not correct. I'm sorry. I just the first two things that came to my mind. Ban me. Yeah. Let's call it that's a donkey, and that's Bob. There we go. Okay, that's better. So Bob is an int, and ass the donkey is also an int. So then you know that you've got these two in scope, so you can use them. And what it does give you like a little. Does it give you? Yeah, here we go. And sometimes it gives you valid holes that might fit. What might fit in there? So it's saying, well, you might be able to use, the value refinement holes include, you can use all of these guys, which is kind of like handy. It's like saying, oh, it gives you options basically as to what you might. So it does two things of type holes. One, it gives you like what your functions, the types of these variables here, these declarations here. And then secondly, so it'll give you, so say you're like in a nested function, it's real deep. It'll give you everything that's in scope to that specific area that you're in. And secondly, it will also try and predict for you what might go in there. I mean, come on. It didn't give us plus though, does it? Does it negate? Oh, it gave us negate. That's not bad. There we go. Let's try that. So let's go. What's it going to complete? It's surely. Okay, so found a hole of int. Yeah, so it knows that negate expects a single. I mean, you can then also, because I've got the Haskell language server, you can see what negate is, the type of it. So if you look here up the top here, it's basically saying for all A, so it's one value returns another value of A. Okay, so it's unary negation. So you know that you've got the ass and Bob that are able to be used in there. So if you look, valid hold fits included Bob, ass, or you can keep going. Try and use one of these. So yeah, it's super handy. So I know here I can use Bob and it'll be happy. Okay, and then it'll give me an error that, well, you're not using ass anymore. So you can do okay, let's explain. Here, when you've got an underscore on this side, it's just saying ignore that value. Okay, but if you then on the right hand side, because everything has, you got to think everything's, so the left hand side, and then so that's a name, and then that's the type declaration. That's the name, that's the values that you pass in, and then there's the body of the function. So anything on the left doesn't necessarily work like it does on the right. So you know when you I don't know, you can't in here, for instance, you can't do that. Okay, it's just not going to be happy. It's good. What do you mean plus? An illegal operator plus int plus in. Yeah, it's just not going to be happy with you. It's like that. You can't do that. Sorry. Yeah, so that's that bit. Type holes, if you need to find out. But that's how I do a lot of things that are really complex. I just use type holes. I'll go from the simplest form, break it down, and I'll go type hole. Okay, let's keep going. Right, let's keep mashing these up. And then you get further and further down, and then it almost writes itself. I say almost, but yeah. Further down, we have already learned how to use different functions and operators in Haskell. Now let's look how they are defined and whether we can introduce our own. We define the function in Haskell. You write its type signature. Yeah, we've done that. Following lines. The type signature should be written immediately from the start of a line. Haskell is indentation and layout sensitive. Yep, language. So this is important to keep in mind. For example, here is the signature of a function that takes a double and an int and then returns an int. So round subtract, that takes a double, an int. We have already seen the, I've gone over it quite extensively, what's going on there. So that's a type declaration. So once you've got here, and this, another thing to keep in mind is this. If you leave that hanging around on its own, it's not going to be happy. It won't. Okay, so let's then do okay, now there's errors. It's saying type signature poop lacks accompanying binding, and again same here. It doesn't. So it's basically it's saying, well, you've given us a type signature. Where's the actual function for it? I know that there's something called round subtract, but there's no function for it. So you can't have that on its own. That's basically what it's saying. We have already seen that. Symbols are in practicing our skills in the GHCI. So when we've messed around, actually, let's just close this quickly. There we go. I've just got double the. Which one is it called? It's. I've got to try and remember. I forget which ones it puts it in. Is it that one? Yeah, no, it's not that one. What's that? Is it? No, that's not that one, is it? Where does it put it? Oh, okay, here we go. That one. Nope. I forget where it puts it. Standard out. Is it that one? LSP. No, it's not that one. There it is. It's up here. It's up here. It's up here. There it is. Okay, sorry. I was just looking for the REPL. I forgot what it calls it. Because I don't. I mean, yeah, it's really useful when you start off, but in general, I'll just use type holes, and that's my way of talking to the compiler without going into the GHCI. That's what I tend. But when you're starting off, it's real useful because you can just play around, and like we've done today, basically. Okay, so the following line should be a function definition start line. Write the function name again and give the argument names in the same order as you wrote. Types followed by the equal signs, and I've not read that properly. I've read it in freeze. You write the function name again and give the argument. Yeah, exactly what I just showed you. Basically, you can't just have it on its own. You've got to then write that name again and then give the body of the function. Okay, after the equal, and then there's round subtract. So you'd basically stick them two together. That'd go, that'd go there, and then that'd be below it. Okay, here x corresponds to double. So like I was doing A and B, it'll be like the first value, that'd be the first here, the second value would be that one. Okay, and then ceiling, so let's have a look at the type of ceiling. Okay, so if you look, whoa, hello, where's it gone? There it is. Again, it's being constrained, but it's so ceiling. The first one's a real fractional, okay, of the class real fractional, and then it'll return us. Oh, why is it going? Does that x and y ceiling? Because ceiling takes a single value, so I guess. How does that work? Let's have a look. Let's have a little look. So that looks a little bit confusing to me. So real, let's go. That's going to be, I don't know. Oh, it's minus. Do it properly. Minus 10. Oh, okay. So let's have a look at something else. I think this is another. Sometimes if things look weird, I'm going to just double check. 1.2 minus 12 message. C and XY can be typed. Oh, and that way. I was wondering if it was this way. Definitely not that way. Well done. Yeah. But that's gonna. Why have they put it there? Because that's kind of like. Oh no. Can it? Let's see if it can be written. Because it's gonna. This is gonna blow minds. If it can do it the way you just said it. What was it? Yes. Let's go. No. What was it? I was doing 1.0. And then minus 12. Same results. Well, there you go. Why it does that? Magic. No, it's currying, but I'll explain that further down. Cool, that's quite handy, isn't it? Yeah, so anyway, that's what it's doing. You can eat. So it's either the result of that, and then you can minus it with that. Or in this scenario, I've done it the other way, where I've minus that and that, given us a result, and given it to ceiling. Magical. But so it takes precedence. I don't know which one it actually. So the minus would be of precedence. I'm trying to think. Let's not worry. We're just like making it worse. Maybe it'll just tell us down here. Here, x corresponds to double y to int. The body of the function can be as big as you want. However, don't forget about the indentation rules. And what is a type of those two ones then? Two ones? I don't know what you mean, the two ones. Give us an example. I don't quite understand it. I suspect yours is a fractional one, whilst the other is a num. Yeah, because it went up here when we looked at the type of ceiling. I saw it had constraints. Where do we do type of ceiling? Didn't we do it? Before we did it, let's do it again. There we go. Yeah, I saw the constraints was 1 to fractional, and it returns us an integral. So I thought I'd pass it so t ceiling that, for example. Yeah, well, the compiler is going to automatically set that into what it needs, which it knows it needs to be a fractional. So it'll convert 1.0 minus 12. It will know that it needs to be a fractional. That's basically how it's done it in that example. I think that's what you're talking about. Yeah. Again, it's if I was to be explicit and go like, let's make it fail. Let's make it. Will it fail? I don't know. What should we make it fail? I don't know if it'll fail. Let's try it. There we go. Yeah. Did I spell it right? Integer, not in scope. Class integer. Ugh. I spelled it wrong. That's probably why. I haven't. Yeah, I have. Of course I spelled it wrong. There we go. So we get an error. Like you said before, with the constraints, that it required a constraint. Well, here, if I give it that concrete constraint, saying it's an integer, then it's going to complain. It's going to go, I can't do a real fractional with integer because I don't find the blah, blah, blah. Yeah. But before we did that, it just assumed that this was going to be a fractional. It just converted it. And then that passed it. And then that took it because fractional is part of real fractional. Actually, let's do something quickly. Let's play around. Why not? I was going to do like this. So type of 1.0. What was it? Minus 12. Except I put 0. Yeah. There we go. Converts it to fractional. So that's how it's well. Oh, okay. Sorry. You can't explain your thoughts and in the text, and my Haskell tools are broken at the moment. Yeah, sorry. We'll just pretend that what you mean is what I'm talking about, because then it makes everyone happy, I reckon. That's how I'm going to go about it anyway. Okay, so okay, go on. I'll do it. So what if you type that way around? So you want to, well, I mean, okay. I mean, you should get a pretty good idea of what the return would be when we looked at the type. Where was it? Have I lost it again? Come on, I'm going to type it in here. I'm not going to type it in here. I'm going to type it in here. Cool. So it's saying it's an integral b of b. Okay. Let's try it the other way. I'm going to try and guess what it's going to be. This is probably, sorry if you're a starter, we're just going off on a slight tangent, which is going to be of no benefit but to us. But we're going to do it anyway. So it's exactly the same. Yeah. Which is expected, I guess, isn't it? Because it's going to do the same, because this is going to return like a single value. So you know when I did that right here, so 1.0, it turned this into a fractional. Well, it's doing exactly the same in this scenario, where that's becoming a fractional, and then it will turn that into a fractional. Integral. Integral? Integral. But integral is part of... Hold on. Oh, maybe you're onto something. Hold on. So that makes it a fractional. Oh, I know why. This is why. This is why it works. Because ceiling can either take a fractional or an integral. So in this scenario, let's go to the first scenario right here. So that we know is going to return a fractional. So we're given ceiling of a. Fractional is part of real frac. Cool. And in this scenario, the type is integral. Yeah. So that is going to return. That's going to return a. What is that going to return? Let's have a look. Let's look at the type of this. That'll probably make it a little bit more. What does that return? An integral. Yeah, which is what our b is. So then that becomes an integral. So let's do integral minus 12. Then integral, and what was the result of that? Yeah, so it's an integral. Yeah. I think that makes sense. Yeah, I'm having an inner thought process right now. Right, I'm going to stop sidetracking because I'm confusing myself and I'm probably confusing others, if anyone else is watching. Now you are ready to define your own functions. In our training, for some function types are provided. For you others, you need to type manually to challenge yourself. Don't forget the main rule: always provide type signatures for top level functions in Haskell. Yeah, that's cool. You can't put round subtract. Where are we going here? Oh, what can I not put? You can't put parentheses around x minus y and round subtract. Up here, I think, shall we try it? There's a bit of code here. Okay. Seems happy. Probably not. No, because, yeah, you're right. Yeah. Because it wants, that's an int, and it's saying that x is a double. So you can't do x. Yeah, no, you're right. You can't do that. So it will get confused. Yeah, you got it right. I think that means I got it wrong. Don't know. I'll take it. Yeah, I got it wrong. Not really sure. Right, let's go into this one. Actually, whoa, thanks for that. What I'll do is I'll turn that off for a second. Okay. This is the other thing with Haskell. Basically, if you use the Haskell language server, you can just cheat. It goes add signature. Is that cheating? It is kind of cheating, isn't it? But it's not, because we've learned how to use a compiler. So that's not really cheat. That's just like we're using a compiler. Next one, we won't do it though. Okay. So we're giving it a constraint of the num class, because this is still quite ambiguous, you know, in terms of like, there's a lot of different, like we've been playing around with fractionals and integers and blah, blah, blah. Well, this we're saying, okay, well, you can still be polymorphic to the num, to constrain it though, only polymorphic to the num class though, not polymorphic to, you know, everything. We're having some sort of limitations here, and this limitation is hit to that. Where is the other one? When we saw the type of int, here we go. This is another way of doing it. You can have multiple here on the right. You can have multiple constraints. So you see how it's going. Okay, A is going to be a real frac, and then B is going to be integral. Okay, so you can have other types of constraints. You can, you know, you can keep them going. And if you want to declare, sometimes you can have 2 to 1 letter. So that can be an integral. Well, the ones that they'd have to match, but yeah, let's just pretend it's not. Cool. So we've done this. So we can see, I mean, how we could have started it. We could have gone, okay, and then it would have complained, going, well, add num a to the context. Oh, it's just like, you know, compiler just tells you what to do. Well, actually, it doesn't. It actually, the compiler doesn't tell you what to do. The Haskell language server tells you what to do. But yeah, we could have started. It would have said no. What we could have done though, we could have also, this would have been acceptable. Like this. That would have been acceptable. We just made it, you know, polymorphic. So we can use it not just with ints, we can use it with other things that of the num class. Implement a function that takes an integer value and returns the next integer value. Next 10. Next -4 is -3. There's actually, it probably won't work if you do that though, will it? Yeah, there's an actual function that's called next. I thought it was. Yeah, but we need to implement it ourselves. What does it give us? Like, oh yeah, it does give us it. So the current function body is defined using a special function called error. Don't panic. It's not broken. Error is like a placeholder that evaluates the exception if you try to evaluate it, and it magically fits a type. No need to worry much about the error here. Just replace the function body with the proper implementation. Another one that you can do is undefined. You can go with that as well. It's just a little bit shorter. That'll just mean that you get to a point where, so a good way to use this is if you're making multiple functions, you know you've got a function that's going to do int to int, but you don't quite know the body, but then you're going to make another function that uses that at some point where you can get it to use it, and then you come back and go, okay, right, so how was I going to work out this int to int? So that just allows it, yeah, like a placeholder, like what they said. Okay, so next, it takes, okay, we won't cheat, but let's try it. So it gives you the next number. Let's see how this does. Okay, so we're going to try it out. So we'll go, can I get to next? I think I can. Yeah, I can. So actually, let me just do something first. Let's call it, oh no, maybe it was just calling a next inside of here. Oh, I don't know, let's have a look. Oh, it was. Yeah, sorry about that. No, but that, you know, that shows you something's happening. So, you know, we have now if we try and, okay, if we try and call next, it won't work. So we have to reload it. At least I've shown you that. So next 2. Okay, that works. Let's keep going because there's another example. Next. -4, -3. Okay, well that works. Yeah, that seems to have done it, doesn't it? So what have I done? I've said is our first input. So in this scenario is a 2. In this scenario is a -4. And then I want it to go to the next number. So I thought to myself, well, if I, it gave us in the example, where was it? Did it give us? Oh yeah, it gives us here. When I call next 10, I want to get to 11. Next -4, I want to go to -3. So like in maths, if you do minuses, it goes backwards, doesn't it? So I thought, well, I know that it's going to be +1 for this one, so I'll put it in, and then I'll try this one, and it gave us -3. Winner, chicken dinner. So after you implemented the function, or even during the implementation, you can run it in a GHCI. Oh, you can do load. Well, you can load the chapter. Yeah, mine sort of automatically does it. But what you can do actually, let's have a look. Oh, hello. That's probably why it wasn't working. It probably wants it explicitly, doesn't it? Yeah, that's probably right. I don't know if you remember. I was like, oh, how do you use in GHCI? Well, this is how. Yeah, and if I call next 1, 2, next 4, 5, yeah, next. What are we doing? -3, -2. Cool. Yeah, I forgot it was load. That's the thing in my one, it does that. It pre-does that, so it has it in there. I should remember that. Sorry. And reload R, which is the I think L is just for load, isn't it? There, load. And R is just for reload. Boo, and it reloads it. Okay. What's the time? 22. Oh, I'm gonna go to. How much we got to go here? I don't know why it's not showing me my files. Normally I've got a little thing that tells me that. We'll go and see how far we get. So I want to sort of maybe another 10 minutes, and I'm going to call it a day. Yeah, it's only so much you can talk to yourself, isn't it? I guess. So I just had to that massive pause. That was a realization that I've just been talking to myself for about 2.5 hours. Yeah. That's probably why streamers and stuff, they must sometimes I watch a little bit of game. Yeah, I'm in Europe, yeah. I'm in the UK. So it's kind of like 22:40, so it's coming to 11. But the other thing is, I don't want to be on here too long because I've got a partner. She won't be too happy if I'm just on here. I don't play computer games, so I guess there's a bonus there. But if I'm going to be here all night, it's going to be a bit annoying, isn't it? I kind of take up the whole of the upstairs, and then she has to go into the living room and laugh at funny TV, or probably I don't know what she's doing. I think she's making some things. Yeah, getting better here as well. I'm 1 hour ahead of you. Where are you based? I guess it's going to be in Europe. 1 hour ahead. Let me guess. You've probably typed it. I'm going to say Spain. Is that an hour ahead? That's 2 hours. Sweden. Oh, okay. Well, that's close. I was trying to guess by the name. Gaffer. I don't know. W. Yeah. Oh, cool. That's cool. Sweden. Okay. I've gone too far. Got carried away. Yeah. I'll go do this last one. Let's make this the last one. Where was it? We've reloaded. Task 5. Implement a function that returns the last digit of a given number. Last. 42. Use the mod function. I'm glad it gave me a tip. Note, you can discover possible function to use via Haskell. Can you? To give you via Haskell. Yeah, well, we've been going into Haskell. From the Simpsons comic book, Wagaffer, who gives a flying F. That's clever. See, I am the world's worst abbreviation person. But that's good. That's a good one. Who gives a flying... I'll say it, fuck. Anyways. Yeah, that's good. You must be going, what is this guy? Wagaffer. That's kind of... Yeah, Wagaffer. I was pretty close. Yeah, I'm terrible. You know, when you see, like, especially on Slack, people love their abbreviations. Yeah, well, you did right. You took a good one. Mine's CMDV, which is like Command V, which is like Command Vincent. That's basically it. That's all it is. Or Command Vince, whichever way. Yeah, and people only if some people kind of get it, some people don't. But whatever. So we're going to go last digits. It's not giving us a type because I mean, how can it give us a type? So it's saying to us, why hasn't it given us a type? So if, it'll take the last digits. So I guess if we give it an int, okay, if we give it an int, it'll return us an int. So we know that. Fidget, last fidget. Okay, so this we're doing our type again. And oh, good. I'm pressing too many keys. Yeah, it's definitely getting late. Okay. Let's use our thing here. Mod. So mod, we know, returns the remainder of something if we divide it. So how do we get the last digit? Use the mod function. Haskell lets you search Haskell either by name or type. You can enter the type you expect the function to have, and Haskell will output relevant results. Or you can try and guess the function name, search for it, and check whether it works for you. The last using mod. This is where I should know this stuff, shouldn't I? Let's have a little play. Why is it not happy? Why are you not happy? Divided by 0. Oh yeah, you can't. Oh. I'll try and remember how you do it. Yeah, it does, but then if I... Okay, so let's try. If I do... I mean, true sign of my mathematical inabilities. 0. Okay, let's try. I like it. Yeah, I was going to say, it's not going to... I was literally going to start doing that. Oh, hold on. That's worked. Well, I've learned something mathematical today. How to get your last number. How good's that? There we go. We learn. I'll just put it out there. Well, I mean, yeah, it's less off for me. I was going to start with like 0. Obviously, you can't do 0. What's amazing is that, you know, I can do lenses. I know monad transformers. But when it comes to mod, I'm out. Amazing. That's cool though. Okay, so I'm going to note that. So how's it? So modulus is obviously it's the leftover of divided it by 10. So is it always going to give you one? So it's much like when you... Oh no, I'm trying to work it out. Yeah, I'm going to blame it on it's being late. That's what it is. Totally. You know what? Oh, I've got one more task. Is it going to be... I don't know. Maybe I'll stop there because that's kind of like a positive ending. You know, I think that's quite good. Task 6. How many tasks is there? 7, 8, 9, 10. 6. That's like over halfway. It'll probably go a bit quicker because we're digging in if I do another one. Probably a little bit, maybe in the week at some point. Yeah, I'm not going to do... I don't know if you watch Vlad, but he streams almost every day. What a champion. Yeah, I'm not that good. Well, I'm not saying I'm not that good, but as in, I can't be asked to do that much. I'm not as. I'm just looking if someone was available because I'm going to stop, I think. But what I'm going to look for is I was meant to like raid someone else, wasn't I? And I've lost the name. Can I find it in history? Where was it? I'm looking. I forgot the name. Did I save it? Hold on. It'll be in history. Was it at someone? No. Oh, there's a lot of copying and pasting in here. Maybe up here? No. Oh, I'm looking through chat who I was meant to raid. Because you might as well learn how to raid because I haven't got a clue. There it is. Tot. Yeah, I don't know how you do it. Come on in, let's experiment. Oh, I've done this thing which I wasn't meant to do. Twitter. Twitch. Stream manager. Hey, oh yeah, I should sort of have an outro. Thanks for coming, everyone. You know, I hope it's all right. I got a bit tired. Maybe I should do them a little bit earlier if I do these things like that. But yeah, cheers for all the follows, the sort of stuff you say. Click and subscribe. Oh, here we go. Let's see now. How do I raid a channel? That was a lie, wasn't it? Did I do an app? I mean, how am I going to raid this channel? Let's have a look. Can you search for people up here? I guess. There it is. Oh. Yeah, well, we're not going to raid someone that's clearly finished before me. Sorry. Is there an about? Let's find out. Yeah, maybe sometimes we should leave names and stuff. Oh, it was a cool name, wasn't it? Was it Reed, I think? I don't know. Don't know what it was. Cool. Anyway, on that note, I think that I'm going to call it a day. You're going to see this. It's all up. Look at this. Blah, blah, blah. It's when you open. Cheers for coming. And oh look, it's all on the side. I didn't actually check if all this looked good, but it does. And yeah, hopefully see you guys soon. And people and girls and dogs. Hopefully lots of dogs and cats. I prefer cats. I'll call it a day. Cheers. Yeah, no worries. Have a good day. See you later, everyone. Evening.